Good afternoon, ladies and gentlemen. Welcome on board Elecard Webinars. Our today's webinar is dedicated to Elecard StreamEye tool. It's a video codec analyzer software. The focus of our today's webinar is how to use StreamEye for broadcast equipment manufacturers, TV service providers, and content creators. You probably met me or one of my colleagues at IBC exhibition in September. For those who I met, I'm glad to speak with you again. And for everyone else, welcome to Elecard webinar. We hope that it will be helpful for you and will help you to do your business better. Shortly about our today webinar program. I will focus mostly on how to use StreamEye for a couple of particular tasks, how to validate compressed streams against the standards with StreamEye, how to compare different streams to each other in order to understand what's the quality of compressed streams, and how to ensure the system interoperability when a product is replaced or upgraded in order to support new formats. As you are looking, we are starting with a presentation, with a short presentation about StreamEye. Consists of a few slides, and then we will move to StreamEye live demo. A few words about StreamEye supported formats. It's the first questions that we receive from our users, from StreamEye users. What codecs do you support? StreamEye supports a list of codecs that you are currently seeing at your screen. They are MPEG-2, AVC or H.264, HEVC, high efficiency video codecs, or H.265. HEVC is currently widely used by OTT providers to stream video over public internet networks, because HEVC allows to significantly reduce bitrate in comparing with traditional AVC video codec. And we also support in StreamEye codecs like VP9, and end of January 2018 we will start to support AV1, a video codec standard. It's going to happen again in January next year, because end of December this year bitstream will be final. AV1 bitstream, AV1 codec algorithm will be finally fixed by developers, and so we will be able to support it with our StreamEye tool. A few words on essential features of StreamEye before we move to live demo. StreamEye, of course, allows to work with videos up to 4K video resolution. It allows to work either with one or two video files using graphical user interface, as well as automated analysis of media streams using console mode, which allows to use a bunch of media files and set up parameters using XML file. We will focus on this feature later during live StreamEye demo. StreamEye, besides features I listed, StreamEye as well supports to calculate, to compare several video files to each other and calculate quality metrics such as PCNR and a few other metrics that you see on the screen. So let's move to StreamEye live demo. I'll switch to sharing my desktop where I have StreamEye application running. Okay, so here we have StreamEye application. It's running currently on my laptop, which has Windows 10 on board. Let me also say that StreamEye supports Windows operating system and Mac operating system. My screen resolution is 1080p. It's a Full HD screen. And currently we are looking at video stream. I already opened a video stream in my Streamy application, and currently we are looking at the stream which is called Big's Bugs Bunny. It's a very popular traditional cartoon used by codec developers and to demonstrate tools. I will focus on different Streamy application functionality, starting from Streamy software windows and tabs that you are currently looking at. Let's begin with the first, which is called bar chart. Currently, you are looking at the bar chart. It's located on the top of Streamy window. Bar chart, as we can understand from its name, it shows all frames that opened video consist of. By bars, by bar colors, we show different frame types, and by bars height, we show a size of the frame. I can navigate quickly through the bar chart to find some interesting place that I want to investigate more in details, and then I can basically navigate over frame with my mouse cursor and see some essential information about the frame. For example, currently my mouse cursor is over frame which has blue color, and from the tooltip we see that this frame has p-type. It's a p-frame. We see its stream order, display order, and some other information. So why it's important to look at the bar chart when you open your stream? First of all, because you can understand visually what is the GOP structure of your stream. So as I mentioned, by blue color we show p frames, and by red color, if I navigate my mouse cursor to red bars, we see that bars represent iframes. So red bars, they represent iframes. So everything between iframes from this iframe, for example, till next iframe, so this is a GOP. So by looking at the bar chart, we can visually understand what's GOP structure. So for this stream, we clearly see that between iframes we have p frames, and there are 3 b frames which are represented by green color. So there are 3 b frames between p frames. What else? By quickly navigating through the bar chart and looking at bars heights, we can understand if the stream is compressed with constant bitrate or variable bitrate. So for this stream, obviously it is variable bitrate, because we see that bars height are very different from each other. There is another way how to understand quickly what's the bitrate of the stream and how it's changing all over the frames, through the frames, is to there is a line on top of the bar chart that you see by red color, represented by red color. It's a red line, and in the top left corner of the bar chart we see that this line has named bit allocation. So bit allocation represents bitrate of the stream, and if we are again navigating through the bar chart, through the frames, and we see that the red line is changing, going up and down, means that this stream obviously has a variable bitrate. So at this place, for example, we look at part of the video or scene of the video with higher bitrate, because bars height at this part of the video they are high, and so the red line, which represents bitrate of the video, is also located higher than in other parts of the video. So this is what you can do quickly when you open your media file. Just go through the bar chart to understand what's GOP structure. There is, of course, there is another way how to understand GOP structure, is to look at the general stream parameters. So let me make this window smaller because again we are using Full HD monitor. So on the left side of the window of the StreamEye application window, we see a window called Stream. So currently I'm browsing this window. So from this window we can understand general and most important information about our stream. Currently we are looking at stream encoded with HEVC video codec, and this is what I can understand from a stream window. Profile of the video stream is not available, or in other words cannot be detected by StreamEye, because probably some headers are related to describing of profile of the stream. So those headers are not presented, or either not presented or have some empty values. So StreamEye cannot detect from headers what is the profile of the stream. And by the way, this is the it means that some playback equipment like set-top boxes may have troubles with playing such streams when profile cannot be detected. So imagine you have a set-top box, and specification of set-top box says that it is possible to play HEVC video, and you actually try to play HEVC video on your set-top box, but it doesn't work. Either it cannot be played at all, or it's the playback is slower than expected, or a video constantly freezes, and you have other problems. So that could be because set-top box supports playback of HEVC stream encoded with basic profile, but you are trying to feed HEVC stream encoded with high profile, for example. Or so it's important to look at the profile parameter to understand what's the profile of the stream, not only what's the video codec of the media stream. So this is HEVC video stream. Then we see the resolution of video picture, frame rate. We see the declared bitrate, which is undefined. Means that there is headers at the beginning of the video stream, which those headers which should describe what's the bitrate of the video stream. So those headers, they are empty. So this stream is not really correct in terms of standard. So if you receive, for example, streams from content provider, and then you push those streams into your video on demand server or into your network for any type of playback, then you may ensure that all of your streams, they are correct, and all headers presented and information about this stream is correct by looking at stream window. And then we have some more detailed information about different type of frames that stream consists of. So we see how many iframes, P and B frames our stream has. So, well, by looking at, for example, if you compare how many iframes we have, right? So we have only around roughly 3% of all frames from our stream, they are iframes, only 3%. But then look at their size. So let me make this a bit bigger. So if we look at number of frames, so iframes, they take only 3% of the stream, but they take most of the data from the stream, and that's obviously because iframe is encoded as a separate standalone picture, and there is no relationship between iframe and any other frames. So that's why iframes, they have larger size. Well, it's also possible to understand again by navigating using bar chart. We can see that bars with red color, they are tallest. It means that iframes have largest size, biggest size. And so from looking at this information, amount of different types of frame and size of different types of frame, we can quickly understand if our stream is encoded efficiently. Because, well, if stream is encoded efficiently, we would like to have less amount of iframes and more B-frames, because B-frames, they have smallest size, which you can also see from the bar chart or from their stream window. We see the total size of all B-frames inside the stream, so we see that they take smallest amount of data. So we would like to have more B-frames and less iframes, and we also want to follow GOP structure. So there is a very traditional requirement to transport stream which are going to be delivered over networks and played in real time. There is a requirement that GOP size should not exceed, for example, 1 second or 2 seconds. So we can look at frame rate. Here again we have 25 frames per second, and then we can go to the window which is called statistics. I'm currently looking at statistic window, and we see that the distance between iframes is 32 frames. It means that our GOP size is 32 frames, and comparing it with frame rate of our stream, which is 25 frames per second, we can roughly understand that our GOP size is around 1.5 seconds. Means that the stream is good to be played over network in real time. So why GOP size should be small is because when we lose iframe due to some skipped block or everything, when we deliver our stream through the network, imagine that there is a data loss in the network and we lost some part of iframe. If we lose some part of iframes, it means that all of frames till the next iframe cannot be decoded correctly. Either they cannot be decoded at all, or they can be decoded only partially, and so basically our user who is looking at this stream which is played live on his set-top box, he will experience some playback issues until the next iframe. So maximum time is 1.5 seconds, which is not that large, which is not that much amount of time, which is good. So roughly for around 1 second, there will be problem with playback if we lose some packets which belong to iframe. So this is how to quickly understand information about GOP structure and if stream was compressed efficiently or not using stream informational window. What's next? What's interesting next? The next is, okay, we already reviewed the bar chart. By the way, I mentioned that if we lose iframe or parts of iframe, if we lose some packets from which belong to iframe, then we are not able to decode all other frames till the next iframe. Let me show you quickly why. That's interesting. That's interesting to know. So let me click on the any frame within the GOP. So let me click on this, for example, P frame. Okay, so that's a P frame. We look at the big bunny. Okay, it's a P frame. If we look at the bar chart, then we see that at the top part of the bar chart we have a couple of circles, red circles. So those red circles, they are actually they point to reference frames for the current P frame. What does it mean? It means that our current frame, parts of our current frame, those parts called macro blocks, or for HEVC video they are called coding tree units blocks, or CTU blocks, or coding units blocks, depends on size. CTU blocks or CU blocks, so but let's call it blocks, macro blocks. So it means that some macro blocks from our frame, they are predicted, or they are predicted from reference frames, and they depend on the information inside reference frames. So if we lose those reference frames, we cannot correctly decode current frame. So it's also possible, of course, to see exactly which blocks of the current frame are predicted and depend on those reference frames. So on top of the current frame, I can put information which is called types. So types information show me type of each macro block on my current frame by different colors again. So by red color is the by red color we show blocks which do not depend on any other frames. So they are compressed as a single picture, as a standalone picture, similar to the iframe. But by blue color we show blocks which are predicted from reference frame, means that they depend from information which is located inside reference frame. And when I navigate my mouse cursor over these blocks, you see that marks on the bar chart, two circles, they are changing. You see, yeah, let me just find a couple of blocks. Yeah, you see that those marks, they are changing. Means that this block, for example, is predicted from the frame which is currently marked with full red circle, and and this block is predicted from another p frame which is currently marked with a full red circle on the bar chart. So obviously, if we lose one of that frame, that current CTU block, the everything which is inside white square, where my cursor currently pointing at, so everything inside this area cannot be decoded correctly. So let me quickly back to the bar chart. So and then I click on p frame, and you see it has references, and then another p frame has also references, and then the first p frame right after iframe has reference to the iframe. But if I click on the iframe, it has no references. It has no references at all, and you see that all blocks on iframe, they are encoded as a standalone picture. It's called intra predicted or intra predicted blocks. And well, so that means that if we lose iframe, then our next p frame cannot be predicted correctly and cannot be decoded correctly, because p frame has reference to the iframe, means that we need to have decoder needs to have iframe in his buffer in order to predict p frames. That's why short GOP, which is around 1 on 1 or 1.5 seconds, is important, because again, if we lose iframe, then we cannot correctly decode all frames until the next iframe, because they all related to each other and finally to our original iframe. This is about working with different frame types and GOP structure using bar chart. There is another chart called thumbnails, which allows very quickly navigate just using our eyes. If we know which scenes our movie consists of, then we can quickly find that scene just looking at the thumbnails and click on it. There is also frame types at the bottom of each thumbnail, so just different way of representation of our screen. Back to how to ensure that our stream has no problems. Let's look at the window which is called message window, which you are currently looking at. In this message window, we have 4 messages. So those messages, they are actually warnings or errors found by decoder, by StreamEye decoder, while decoding of this stream, of this video stream. So you should look at this message window in the beginning of analysis of your media stream, right after you open it, to make sure that there is no troubles, there is no codec issues found by decoder. Because if there is issue found by decoder, that means that another decoder, set-top box decoder, or any other software or hardware-based decoder may found this issue as well, and then it may behave incorrectly while playback of this video stream. Either it can drop frame, or it can decode frame not correctly, or either make some even worse situation like freeze or equipment restart or set-top box restart or other troubles, especially if this is a hardware decoder. So our current stream has 4 issues. We have text explanation of the issue, details of the issue, including reference to the specification item. So we can, again, if you got your media library from content provider, then you can quickly check all of your streams, looking at message window, and then deliver all these messages to your content provider and ask him to explain why his streams have these errors. There is also offset or position associated with each error. So when we click on the issue, you see that at the left side of StreamEye application window, there is another window called Stream Viewer. And when I click on the message, Stream Viewer automatically navigates to the particular header of the stream where this issue is located. So we can open that header and see some details about this header. Yeah. We can see some details about this header. We can check it ourselves if we have enough experience to understand what all these parameters mean, or we can just, as I mentioned, simply deliver this errors back to the place where we got our content and ask them for explanation. Another way how we can check if our content is valid and there will be no issues during playback of our content is to look at the buffer window. This is extremely important when we talk about content which has to be played in real time. If there is a real-time live streaming of our content, imagine you have a TS file, and then you put that TS file onto your video on demand server storage, and so this file will be delivered live to a set-top box, for example, which has a hardware-based video decoder. So we are currently looking at window which is called buffer. In this window shows usage and fullness of the decoder buffer. If we go back a little bit to the part where I explained about a relationship between current frame and reference frame, we now can understand that our decoder has to keep somewhere in his memory not only current frame that he's currently decoding, but also reference frames, because decoder needs those frames to decode our current frame. So that is called decoding picture buffer. So that part of memory, of the decoder memory, called decoding picture buffer. And we can actually have a look in that buffer and see. This is currently we are looking at the decoded picture buffer, and we see what frames are located there. We see that there is only one frame, because current frame, if you look at the bar chart again, because our current frame, which is P frame, this is our current frame, P frame. So our current frame has only one reference frame, which is I frame. So those I frame is located inside our decoding picture buffer. So that's the buffer, and there is 2 situations which may finally lead us to the problems during live playback of video streams. So those situations are buffer overflow and buffer underflow. So at this graph, which you are currently looking at by red line, we show current fullness of the buffer and how it's been used during decoding of the whole stream. So we would like to avoid, as I mentioned, buffer overflow and buffer underflow situation, because when decoder experience buffer overflow, it means that there is no left space inside decoder buffer to keep and to store new incoming data. And because this is a live stream, and if decoder has no space to store incoming data, it has to skip that data, because this is live stream again. And if it has to skip those data, imagine that he needs to skip iframe, and so we have a big problem for the next second or even longer, because iframe, we lost iframe, so we cannot decode correctly everything till the next iframe. Buffer underflow is also dangerous situation, means we have no data to display, no data to decode, and decoder have to either to show black screen or just to freeze current frame. So there will be frames freezing situation during playback. So that's because of buffer underflow. So by quickly navigating through this window, we can find if we have buffer overflow, underflow situations with our stream. And on the left side of this window, we also show what is the buffer limitations set by encoder when encoder encoded our stream. So we see that buffer size is 3.3 megabyte. So that's the declared buffer size, and so that's the maximum buffer size set for this stream. Again, if decoder that will be used to play back our streams, if that decoder is hardware-based decoder, set-to-box decoder, so those decoders tend to have smaller buffer size, smaller maximum buffer size, because again, that's a hardware chip. It cannot basically allocate as much memory as we need during initializing, during playback of video stream, because that's not a software-based decoder which is running on our computer, and our computer has 8 gig of memory, so as much data as we need we can allocate, but for set-to-box, no. So we need to look at when we analyze our streams, we need to look at what is declared buffer size. Again, for current stream it's 3.3 megabit, and we need to check if we have buffer overflow or underflow situations. Now I would like to move to another interesting part of our live demo, and we will be looking at how to compare and how to understand quality of streams, how to compare two different streams to understand which one has higher quality, or how to understand what's the quality of our current stream. I'm going to open a couple of another streams, but before, let me let us imagine a use case. Imagine that we just purchased new encoder equipment, or we would like to purchase encoder equipment, and we want to understand which encoder gives us better quality for the same bitrate. We have, for example, we are OTT provider and we have limitation. We would like to push full HD video streams with 2 megabit per second bandwidth, and we would like to understand which encoder, which codec can give us better quality for this 2 megabit per second bitrate full HD video streams. So we take encoders, several encoders. We take and imagine our source is SDI, so that's uncompressed raw video. So we produce several video files made by different encoders. All files, let's say, encoded with 2 megabit per second, and then what we do, we compare our files with our initial raw input, and to understand what's the difference between encoded video file and raw input, and how much data actually encoder decided to skip in order to squeeze our video into required bitrate. So I'm going to open a couple of files. So I have here a file which is encoded by YouTube video codec. So when I open my file, I can see basic information. So I can see that my file is AVC video, Full HD, 50 frames per second. I select it, and it's going to work. So let me. Okay. So here is the file. Again, I can navigate through the bar chart. I see my bitrate line, which is more or less flat, but it's still not constant bitrate video. Again, let's move to the stream information. I see that this video is AVC encoded with high profile. Okay, Full HD resolution, 50 frames per second. And switch to statistic. We see that the distance between iframes is 256 frames. So in comparing this with 50 frames per second, with current frame rate, it gives us around 5 seconds. So GOP size is 5 seconds, and we see it on the bar chart. So iframes are really far from each other. Let's go to the message window. We have no problems with the stream, which is good. The buffer information is not presented, which is not good for this stream. Means that there is no data associated inside the stream associated with buffer information. So encoder didn't declare what's the required buffer size for this video, and it means that our decoder has to decide it himself, probably by just allocating maximum possible memory that he has, if it's a hardware decoder. But okay, so how to understand what's the quality of this video? We need a reference video, so we need to compare our compressed video stream with the stream which was used as original source to produce our compressed bit stream. I'll avoid some screens just to make it bigger. Okay, so we go to the StreamEye menu called reference, and we open our reference. I have here reference, which is the same. Just to quickly mention that because reference media files, they are raw, not compressed, and so there is no headers explaining what's the color space of our reference file, so we have to choose it ourselves. And so I went to the reference informational settings, where I can, so this is my reference video file. We see the resolution, and this is the color space. So I can quickly change the color space, and I see that the picture is broken. So that's for sure that's not the right color space for my raw reference file. So this is the right color space because I see no troubles with picture. So when I see no troubles with picture, I just click OK. But by default, StreamEye uses the most common color space. But again, they could be different, so we can change them. So when we opened our reference window, we see that we have one more tab called reference. Currently, I'm looking at reference tab. Again, here is the decoded, here is the reference. So let's zoom to see what's actually going on. So let's look at this. Let's look at these people running somewhere. Okay, so this is the reference picture. High quality, uncompressed input raw video stream, Full HD. And this is what we see after decoding. We see that, of course, the quality is significantly worse. And let's quickly again check what's the parameters of the stream. For Full HD 50 frames per second, bitrate is changing from 3 megabit till 7 megabit per second, and the average is 5.5, which is for Full HD video AVC 50 frames per second, 5.5 megabit per second is okay, but you will be looking at the picture like this. My colleagues just informed me that we have a question in our chat, so let me quickly see what's the question in there. Okay, okay, we will answer, definitely we'll answer this question a bit later when we will move to this part. So now we would like to calculate some quality metrics between these two streams. Okay, by our human eyes we understand that there is a difference, but we need some numbers because we have several encoded video files, and then we will use that numbers to understand which encoder gives us better quality. For this purpose, I can again go to. For this purpose, no. Let's first do it in a bit more interesting way. I have a button here on the StreamEye interface called Difference. So when I click on this button, I'm able to compare two different frames. Could be any frames. I mean frames on different decoding stages. But I'm interested to compare our decoded frame with our reference. Frame, and I'm able to compare it using different visualization way. So let's compare it using temperature. So, and now I have another tab called Difference. So I click on the tab called Difference. Let me zoom it out, and so we see that here is the difference between our two frames. If I click on another frame, then because currently we are looking at I frame, which is the first, so I would like to actually look at somewhere in the middle. Okay, so this is the B frame. So by looking at this difference picture, we can see which parts of our frame are most different from our reference. So by color we represent how big is the difference. Black color almost no difference, and then blue color more difference, and then through green, and then finally to red. So by red dots or by red color we represent areas which differ from our reference video. Another way is to calculate PCNR. Calculate PCNR for the whole frame, and now we see that each block has value from 0 to 256. It's actually not real PCNR, it's PCNR clip, means that we took our calculated PCNR region and just extrapolated to values from 0 to 256 just for better visualization. And so we can see on this picture which blocks, which areas of our picture has higher PCNR values, or we can just look at the original PCNR, which is not that easy to look at. But this is for the current frame, and more than this is for different blocks on current frame. How to get it. How to get a number for the whole frame, and even we are interested in understanding PCNR number for the whole video. So on top of the bar chart we can place another information which is called metric, and currently metric is PCNR. In order to let StreamEye calculate this metric, I have to go to the first frame and actually click on the play button again. And you see that, so there is a play button first of all on StreamEye, so you can click play button and StreamEye will be playing your video stream. Not in real time, because it has to do lots of calculations associated with displaying of each video frame. Currently, and so currently StreamEye is also calculating what's the PCNR for each frame. So I can pause whenever I want. I can pause StreamEye, and so we have green line on top of the bar chart, and so that green line is So that green line show us what's the PCNR for different frames. So when I navigate through the frame, I see the PCNR value for the current frame, calculated PCNR value. For example, for this frame, the PCNR value is 19.5 decibels. And then it's 20, 19, 19, and here is smaller, right? Yeah, so here is 18, 17, and the maximum is something like 20. Yeah, so the maximum is something like 20 in the stream information. Yeah, so we calculated PCNR not for the whole stream, but for roughly 30% of the stream. Let's just continue calculation just to get a bit more data. It's interesting to see that how PCNR picture, how difference picture is changing from frame to frame. We also see it in real time. So, okay, so that's enough. We probably understood that the whole video will have more or less the same values. So the values of PCNR we are looking at, this is around maximum, right? So that's 20, and here is around minimum, around 16. So we have from 16 to 20. This is how our PCNR value is changing. So answering the question. Right. So answering the question, which PCNR values, how to quickly say if video has good quality or bad quality by just understanding what's the PCNR value. Well, for this video, PCNR is from 16 to 20, which is considered as actually low quality. So low quality video stream. But so one thing that we have to know is higher PCNR values actually state for better video quality. Lower PCNR values say about lower video quality. Higher PCNR values, high video quality. Low PCNR values, low video quality. So for this stream, PCNR is from 16 to 20, which is actually considered as low quality. But PCNR is a mathematical metric. It doesn't say anything about perceptual, about the perceptual part of the quality. So it doesn't say anything what do we feel about the video quality when look at video stream. Low bitrate encoders like YouTube encoders, they tend to do a lot of video pre-processing before encoding. What kind of pre-processing? Adding, first of all, is removing all the small details from the video stream. So that's like make the video smooth, and then increase sharpness of the video. So it's a bit of cartoon effect. They make video with a bit of cartoon effect during pre-processing, and so it makes encoder allows encoder to encode our stream more effectively with lower bitrate, because lots of details from video picture are already removed by video pre-processing stage. And it doesn't look bad. All encoder manufacturers, they try to implement noise filtration filters, pre-processing noise filtration filters, and another type of pre-processing filters in order to remove details from the video picture, but in the way that we will either do not notice that, or actually we will like that. Because instead of looking at blurry picture consists of a lot of blocks with very visible borders between square blocks, this is what typically happens when we encode video with very low bitrate. We would better prefer to see at the video stream, which looks like a bit of cartoon, because all of the details, they were removed before encoder took that stream for further encoding. So it's like denoising. So that's basically what happened in most video preprocessors. We take the video and apply heavy denoise filter on it. We apply heavy denoise filter on it, so our pictures start to have a bit cartoon effect, looks like a cartoon, and all details disappear, all small details disappear. But this is better. It is better to encode a video picture like this if we really want to encode it with lower bitrate. So, and this is actually what YouTube does. If we look at the decoded video picture, which we can, let me just click play button in here, and so we can, well, there is artifacts around borders, of course, because current playback speed is not a real-time playback. We play like 2 or 3 frames per second only. But you see that all people on the picture, it looks like a very heavy denoise filter was applied before pushing this picture to encoder. There is another questions in the chat. Which parameter shows resolution of the frame? For example, Full HD video can become, in case of we compressed Full HD video really hard, okay, or we use low resolution input. Okay, so yeah, that's what typically can happen when, for example, we look at Full HD video, which has Full HD video resolution and everything like that. But originally that was standard definition video, which was basically upscaled by content provider just to either increase the price of the service, because high definition video services cost more than standard definition services video, or yeah, just to make the content better. The general rule is it's always better to encode video with, if you really want to encode video with low bitrate, you better go for low resolution. You better to scale down the video before encoding and make it really low resolution first and then encode it. The reason why is because when decoder upscales the video after decoding, the upscaling procedure will give us better looking picture. Upscaling procedure will give us better looking picture in comparing with low bitrate, high resolution video picture. Because with low bitrate and high resolution video picture, I'll show you what's going to happen. There is so currently we are looking at compressed video stream, right? So let me just make this window bigger. I'll show you what's going to happen. So currently we are looking at the decoded video picture, but this is actually not exactly 100% what a decoder gives as an output. What decoder gives as an output is this one, is the picture which is called unfiltered. Let me zoom it in so you will see what's the difference. So here is unfiltered picture and here is decoded picture. You see the difference. So you see that for the unfiltered picture we see lots of blocks and borders between blocks. They are very clearly visible. So unfiltered picture is actually the last stage of decoder, but then decoders, they apply a filter which is called deblocking. So that filter purpose is to remove borders between blocks, is to make a picture looking better. And this is what happened to this video. So this is unfiltered and this is decoded. So if you encode high resolution video with low bitrate, your picture will be looking like this, like unfiltered picture. Yes, decoder will apply some deblocking filter. Yes, it will look a little bit better. It will try to remove borders and so on. But deblocking is not as good as upscaling of the video, because today algorithm to upscale video, they are more comprehensive. They have better quality than deblocking. So it's better to encode if you really want to push video with low bitrate but keep the quality. So you better reduce resolution of your video, compress it with a bitrate that you want, and then during decoding stage, all set-top boxes, all decoders, they are able to upscale a video, and upscaled video after decoder will look better than full resolution video encoded with low bitrate. So I believe that I answered this question. So so we understood how we can compare two videos, how we can compare compressed video stream and raw reference video stream. So it allows us to compare different encoders to each other. If we have several compressed video streams, each of them received from different encoder, and we have raw reference, then we can compare all of that streams out of encoder with our raw reference. And one more interesting thing is that we don't really need to do that manually, because currently you saw that I opened one compressed and I opened one reference, and imagine we have like 50 compressed streams. So I do not want to do it one by one manually. And this is why StreamEye has a console mode or automation feature. It allows to create an XML file where you specify first list of media files to work with, and secondly you specify there what actually you want StreamEye to do with those media files. You can specify that, hey StreamEye, can you compare all these 50 streams with this one stream? So you will actually create like pairs. You will create 50 pairs. Inside each pair, the first stream will be your compressed stream, and the second stream will all be the same for all 50 pairs. That will be your raw reference stream. So you will say, hey StreamEye, take these 50 pairs, compare them, and give me back 50 values. And each value is basically PCNR value for the whole stream. And that's all. And then you just pick the stream which has highest PCNR value, and have a look at this visually with StreamEye to see more in details what's the GOP structure of the stream, and so on and so on. If the stream has any errors or even visual problems, you can play back that stream, and this is the way how you can more or less quickly choose which encoder can give you better quality. Again, of course, for this case, you want all encoders, you want to set all encoders to encode video with the same bitrate, the same codec, the same resolution, the same frame rate. Because otherwise, if you change bitrate, then of course video with higher bitrate will have better quality and so higher PCNR value. This is basically that's all. Let me go back to the presentation which we started with, and please feel free to write down your questions in our text chat. Anytime I am able to switch back to our live streaming, to our live demo, I'll go back to StreamEye demo and comment your question or show you some functionality of StreamEye which is not clear. Please write down your questions, and I'll continue a few more words about StreamEye licensing. If you would like to try StreamEye yourself, you are very welcome to do so. We have full-featured demo version, which will last 7 days on your computer. It has absolutely no limitations except of 7 days. So it will last for 7 days, and you cannot reinstall it on your computer, unfortunately. Then we have a free trial demo version, which will last for 30 days. The limitation of trial is you are allowed to work only with first 42 frames of any video streams. So there is no limitations except of 42 video first frames. So if you will try to click further beyond those 42 frames, StreamEye will tell you that, hey, you are using evaluation version. Please contact Elecart. You can install StreamEye either on Windows operating system or Mac. There is a couple of licensing models that we support. First one is a standalone application. We call it single seat license. Another license, we call it floating. Imagine you have a team of 10 engineers, and all of them would like to use StreamEye, but they are located in different countries or different countries. So means that for some reasons, only, for example, 3 of them will be using StreamEye at the same time. So we talk about 3 concurrently running StreamEye instances, and this is StreamEye floating license. You can install StreamEye on any amount of computers that you want, even 100 or 1000, but only limited amount of StreamEye instances will be allowed to run simultaneously. StreamEye also is a part of a toolset called StreamEye Studio. Inside that toolset, we have a couple of another really interesting applications. One of that called Stream Analyzer, and it is designed to analyze transport stream level and MP4 media container. Again, StreamEye is a video bitstream or video codec analyzer tools, means that it performs analysis of video elementary stream only. But of course, we for most cases, if we deal with transport streams, then we want to see what's going on transport stream level as well, and this is the purpose of Stream Analyzer application. It shows all errors according to TR 101.270 protocol. 3 priorities errors allows to show some graphical information and export of errors and some other features. Please subscribe to our next webinars, where we will be focusing on Stream Analyzer and another application. Another awesome application, including StreamEye toolset, called Quality Estimator. That application is focused on quality comparison of video streams. So there is no functionality to work with compressed video stream on that detailed level as with StreamEye. But in Quality Estimator, we are able to compare 2 compressed video streams and 1 raw reference video stream, and we can compare them all to each other or reference stream and calculate calculate another quality metrics, not only PCNR metric. So again, we will be having more webinars dedicated to Stream Analyzer application and Quality Estimator application. I do not see any questions in our text chat, so let me just briefly mention who is StreamEye client. Currently, you are looking at logotypes of European companies who are enjoying using StreamEye. So all those companies, they are existing customers of StreamEye for the last, I believe, 3 or 4 years. And so StreamEye actually is popular and recognized application all over the world, not only in Europe, but also in the United States and in Asia Pacific region. At this point, I would like to thank you very much for your time. Please subscribe to our next webinars. Again, we will be glad to continue showing to you our products related to transport stream analysis or quality comparison of video streams, and we will be glad to be helpful for your business. Thank you and goodbye.